Okay. So for those of you, your friends are not here and you have the time, just text them. In case they're also sleeping, like the last time, yes. Then if you know that you can wake them up, then please go ahead. Jerry, if you can put in the class that teacher has started now in the class group, so at least your friends are aware. Okay. Huh? It's a Zoom user entering the waiting room. I guess it's one of your new friends, I guess. Okay, so we're starting with chemical for consumers. Is your last chapter in Form 5. Okay. Okay, so the first topic is actually oil and fat. Okay, and then it's soap. Okay, but let's read this riddle. I'm sometimes a bar, but I'm not made of gold. I'm sometimes a liquid, but I'm not something you drink. I create bubbles, but I'm not a can of soda that's been shaken. I help to get you clean, but I'm not a shower. I'm found by a sink, I'm not a faucet. What am I? Can I know who is this Zoom user? Oh, Anu. Okay, all right. Anu. Anu, change your name, Anu. What like you? Okay, so this chapter is soap, Form 5. It's called Chemical for Consumers. It's a mixture of so many topics. Okay. The answer is soap. Correct. Very clever. Okay, so as I'm teaching you soap today, I am also going to teach you oil and fat. Okay, so this is all the soaps or most of the soaps that you're going to see. Okay, you got sodium laureth. Okay, if any one of you actually, right, you go to your, um, I think I cannot write here. I need to write on this one. If you go to any of your soaps in at home, okay, you go and turn and see the ingredients, you will definitely find potassium or sodium. So every soap or most of the soap that you see, they must have potassium or sodium of anything. Okay. I'm trying to use this screen because the screen I can write on it. Do you still see this same? Do you see my slide? Can you see my slide? Let me just show you what I'm showing. Okay. Can you see now the slide is on soap? You haven't? Okay. Can you see this screen? Because I changed to something else. So did you see me changing slides? What do you see on your screen?
Oh,
So, okay. So you actually follow through. Huh? So if you're on a different screen from teacher, you let me know, okay? So actually, so is a sodium, and then they like to ask this for definition, yeah? So all of you, if you can write down, this is definition, okay? Soap is actually the sodium or potassium salt. It must be a salt. Can you learn in Form 4? Salt is an ionic compound. Okay. So it's a sodium or potassium salt of long chain fatty acid. Okay, it's a long chain fatty acid, and this fatty acid is 12 to 18 carbon atoms per molecule. Actually, I don't know what you're saying. Fine, it's all right. Okay, so the long chain fatty acid is actually this R. This R here is actually, they have 12 to 18 carbon atoms per molecule. Okay, and then remember teacher said sodium or potassium salt. So here you have sodium or potassium salt, and they have long chain fatty acid. So this is your salt. Okay, this is what makes it salt. Salt is an ionic compound. Akila's coming in. Okay, so salt is an ionic compound. How do you know this is an ionic compound? I've got positive and negatively charged. Positive and negatively charged. So it's positive and negatively charged. Positive and negatively charged. That is a salt. Okay, so this is an example of how your salt and ion will look like. Okay, so remember, soap must have sodium or must have potassium. Okay, and then soap must be must have salt. So usually it is sodium fatty acid. If you're using detergent also can it must be long chain fatty acid. That means I have the R here. This R must be 12 to 18 carbons. Okay, so that's the definition of soap. They like to ask this for definition. Now, teacher want you to memorize the word sapu. Okay, what is sapu? Okay, sapu means saturated, comes from animal fat. Plant is unsaturated. Teacher, I still don't get it. Okay, how do I differentiate a saturated and unsaturated? Okay, so single bond and double bond. This is something I taught you in polymer as well, but it's actually from carbon compound. Okay, saturated. Okay, how to spell saturated? Saturated. Saturated is satu bond. I got satu bond. So good, they have the word here satu. That means I have one bond between the carbon and carbon. Okay, unsaturated is unsatu bond. So unsatu bond is two bonds or three bonds. So between the carbon and carbon, I have two bonds or three bonds. Okay, so saturated is satu bond, one bond. Unsaturated, more than one bond. Okay, what teacher? What is the A? What is the P here? Sapu. Okay, saturated. Afif Arza is coming. Saturated is usually coming from animal. That means cow. Okay, pig. Some of my students recently, when I was teaching them the extra class from 5, they were so excited. Teacher, pig, pig. I'm like, yeah, correct. Okay, so all these are saturated. Okay, if they are animals like butter, okay, butter and all, they come from cow, right? From animal, right? So that are saturated, um, uh, saturated fat. Okay, and then I've got unsaturated fat. Okay, this one comes from plant. So any plant that you see, sunflower oil, okay, or coconut oil, okay, all of these are actually unsaturated fatty acids. Okay, so soap either can be made from animal fat or vegetable oil. Okay, so remember sapu. Okay, you answer for teacher. Saturated comes from where? Very good. It's coming from animals. And unsaturated plants. Very good. Okay, good job. Okay, now what do I do actually is I'm taking the fat and the oil, okay, and I will hydrolyze it using alkaline conditions. That means teacher's going to add sodium hydroxide or I'm going to add potassium hydroxide. And the name of making soap, teacher will actually make soap with you in school. Maybe sometime this week, sometime next week. Since I finished teaching, I can actually make soap with you. Okay, so the name of the process is called saponification. Okay, saponification. Okay, no need to pronounce like that lah. Okay, saponification. Okay, and how to make it a green technology? How? Is when you ask your mommy to fry for you fish or chicken or whatever, that same oil, okay, after she finished frying it, you bring to school. Then the next day, we've mixed soap with it. So can you imagine? You never know. Whatever soap you're using these days, whether it is coming from after someone cooking something. Okay, so I have done this before as well. Okay, making reused oil, using reused oil and making soap as well. Okay, so the name of the process is what? Who can type for teacher in the chat? What's the name of this process? Saponification. Okay, correct. Chris, can you add on? Teacher, I think I gave you 5 or 6 names just now. They cannot make it. Zafran is one of them as well. Okay, add on there. This one all gave teacher the reasons that they are not here, but I still have so many that are not here yet. I only have 18 if you want to exclude Ashwin. And okay, plus 6, 24. So teacher has 11 more that is unaccounted for. And where are they? Kuvan? Kuvan, did you say something, Kuvan? Okay. All right.
Sorry, teacher.
Yeah.
Just now you're saying Zen, Sharvin, Zafran, and who else, teacher? Sorry.
You have to go back to the message all the way to the top. Can you go to the chat? Teacher typed down already.
Oh, okay. Thank you,
All
teacher.
the way to the top. So you actually can put by the side there, beside their name, inform teacher, including Zafran. Okay,
Oh.
so I don't teacher want to say the name list maybe in 5 minutes. So at least I know who's not in.
Sure, teacher. Thank you.
And thank you, Chris. Okay. Okay, so far I think you all get it. Okay, so I just wanna are you coming in again, Christopher, using your sister's name?
Oh, sorry, teacher. Cause my laptop. I had to change laptop, teacher.
Okay, no worries. Okay, I'm admitting you in. Okay.
Thank you, teacher.
Okay, all right. So I've got 2 steps to prepare soap. Okay. One is teacher will actually take a fat and an oil and I will break it up. Okay, I will hydrolyze it. This process is called hydrolysis. Okay, I want all of you to look at this particular item here. Okay, it's fat or oil. Okay, how do you know it's a fat or oil? Teacher, how do you know, teacher, it's a fat or oil? Like, I want you all to know this. Okay, because you haven't learned chapter 2 carbon compound yet, so you'll be confused. Okay, I want all of you to look at this COO group here, COO group here. This COO group here is called an ester group. Okay, an ester group you can usually find in oil and in fat. Okay, teacher repeats so whether you can, teacher want to ask this question, so I want to check whether you understand. Okay, what is the name of the homologous series that I can find in oil and fat? That means when I look at this, how do I know that this is an oil and fat? What is it there that shows me that it's an oil and fat or fat? What group is that? Or what do you see here that you know, hey, I think this is oil and fat group? Okay, if you're not sure, they're just going to say it again, yeah? Correct. It's an ester group, okay? So you have COO here. Okay, COO, COO, and COO. Okay, this COO is called an ester group. So teacher's going to ask this again. How do you know that this is an oil and fat? What must oil and fat have? So a lot of you are here in the class, so I want to see most of you answering in the chat. What? Very good. Is COO correct? Ester group, COO, ester. Jishnu, you straight away get wrong. What's wrong with Jishnu's answer? So in chemistry, we're very particular about spelling. Yeah, if your spelling is wrong, it's wrong. Okay, so it must be ester without the H. Okay, all right. So now let's look at this group. Is this oil and fat? They're just circling to ask you, is this oil and fat? Do you think they are oil and fat? The one that I just circled. No, very good. It's not oil and fat, sorry. Why are they not oil and fat? Very good, because I do not have a COO. Okay, but what I have is I have an OH, so it's actually an alcohol group. Okay, and when teacher have COOH, this is a carboxylic group. Okay, so you can write down as teachers write it down, or you can take a picture, you can snap. At least you know. Later when I teach you in carbon compound, you roughly know it. Okay, Tanisa is coming in. Okay, actually I'm a bit confused with, I think I have Tanisa, I have Ame, I have Ashwin, Arshana. So the 4B is here, 5B is here. Then I don't have many more 5A, that means. I don't have Avinesha here. I don't have Ashman here. I don't have Fatin. Fatin is here. I don't have Hafiz. I'm just seeing the one that I can't find. I can't have Simi here. I don't have Teja, Tava. Yeah. Narmata also teacher don't have here. So if you hear me calling their name, can you please get them? Rugi, they don't listen. Okay, because I won't repeat. Okay, and then it's you who, your friends who will not get a chance to listen. Okay. All right. So let's move on. Okay. So what teacher did here is, okay, this is a bit hard for you to understand, and you don't need to know also. Teacher actually broke the bond here. And when I broke the bond here, I put a hydrogen here and I put a OH here. Never mind, not important for you to know. Okay, I don't need the glycerol. I want the fatty acid. Okay, teacher, how you know it's a fatty acid? Okay, I know it's a fatty acid because I got a COOH group. It's a carboxylic acid group. Okay, so teacher asking a class again, how do you know that this is a fatty acid group? How do you know that this is a fatty acid group? How do you know this is a fatty acid compound? What does it have? Very good. Very good. It has COOH and carboxylic acid. And for making a soap, I actually want the COOH only. So see, look at my second example here. I took my COOH and I reacted it with sodium hydroxide. Must have sodium hydroxide. When you want to make soap, you must have concentrated sodium hydroxide or concentrated potassium hydroxide, concentrated. Now look what happened. I took out the water here and my sodium went inside. So basically, I want all of you to look at this and I want all of you to remember what teacher said about the definition of soap. What did I say was the definition of soap? Who remembered from page 1 just now? Very good. Okay, it is a sodium or potassium salt. Okay, let's write it down. It is a sodium or potassium salt. Okay, let's see whether correct or not. Yes, I've got a sodium here. It's not potassium. And I know it's a salt. So this is a COO here with an Na. Okay, perfect. Sambung. It's a sodium or potassium salt of what? Do you remember? Very good. Of long chain fatty acid. Thank you, Chris. Okay. So this is your long chain fatty acid, which is your R group. Let's count how many carbons we have here. Okay, you've got 14. Okay. And you've got 1 here, 15. So remember, I told you the R can be from 14 to 18 carbons per molecule. So basically, I don't care about anything else. Basically, I wanted to get the water. Sorry, the soap here. So I went through two processes. Process number 1 was I hydrolyze it. It's called hydrolysis. And then the next step here is neutralization. Teacher, how you can say this is neutralization? Because number 1, this is an acid. Number 2, this is a base. Number 3, I told you what? I'm getting salt. And number 4, this is water. So the process of making soap involves hydrolysis and neutralization. Okay, so far do you all understand? Okay, give a 1 if it's a yes and a 2 if it's a no. All right. 3 students. Where's the rest? Where are the rest? Okay, I'm just going to go through the names here because Christopher already put in. Aaron is not here. If somebody can get Aaron until today. Did Amelda come to school today? Okay, can you ask Amelda to come and see me tomorrow? Yuga, if you can get Avinesha. Who's Ashman's friend? Anybody know who's Ashman's friend? Ashman got no friend? Okay, thank you, Adam. Okay, Adam said that he is gonna call. Can I have Afif, if you can call Tava, Teja, Rishan, please help to call Teja. Jinjing also excuse Chris, if you don't mind adding for teacher. Jinjing is also excused. And Narmata, can I have Tanita calling Narmata? Did I miss out anybody else? Okay, all right, thanks. So we'll just leave it as it is now. Teacher will continue. All right. Okay, maybe all fallen asleep really. Go back home first day of school, do nothing, also can fall asleep. All right, so let's go to saponification. Okay, so saponification is I take the fat and oil and I react them with concentrated. If you don't have the word concentrated, you don't get any marks. Okay, sodium hydroxide or concentrated potassium hydroxide. Okay, teacher will get glycerol and fatty acids. Okay, so this is saponification. So let's have a look. Teacher, oh my God, this is crazy. Okay, all right. Have a look at this. How do I know that on my left hand side is oil and fat? How do I know it? There, oh, that's a lot of COO. Very good, huh? I've got a COO, COO, COO. So basically, teacher is going to hydrolyze it. But here, what happened here is they straight away did both steps together. They straight away did the neutralization together with the water. Okay. So here they already put sodium hydroxide here. Teacher won't waste time teaching you how to do it, yeah, because it's beyond you for now. Okay. But basically what happened is teacher breaks the bond here. Okay. I'm just showing you in case some of you are intrigued to know, teacher, how does it happen? Okay. And the hydrogen, okay, goes over here. I got 3 hydrogens. So each hydrogen will go here. And then the O and A will go over this side. So that's why you get R, R, C, O, C, O. Then you take the O and A from here, O and A. So this is the soap that teacher want. In exam, how will they ask you? They can ask you the word. Okay, they ask you the word formula. Okay, so you must say oil plus fat, O fat plus alkaline, you are going to get glycerol, okay, plus soap, okay. And then teacher, how do I know what is a glycerol? Glycerol is actually alcohol. It must end with OH, OH, and OH, okay. So that's how you know. Okay, so basically, let's look at the experiment, okay. I'm gonna take the acid. I'm gonna take the fat and oil. I hydrolyze it first. Okay, after I hydrolyze it, did you get the glycerol and fatty acid? I take the fatty acid, I react with alkaline, and I will get sodium or potassium salt. Okay, now which one you prefer? You think potassium is better or sodium is better? Which salt is better? Sorry, which soap is better? Sodium soap or potassium soap? The answer is right in front of you, yeah? Huh? Jishnu is saying carboxylic. No. Teacher's asking you which soap is better. Potassium, yeah, correct. Potassium soaps are much better because they are softer. So again, I want all of you later, when you go back, when you're going to shower, take out your soap, take out your shampoo. You go and find for which soap they usually use. And it's always usually potassium. They very, very rarely use sodium. But in school next week or the week after, teacher will actually use sodium hydroxide with you. Okay. Now this is how we prepare the soap. This one teacher will do the experiment with you. So no need to worry now. Teacher will teach you. So these are some of the examples of the soap that we got before. Okay, this is my 2020 child. Okay, she got the soap and then she shaped it. Okay. Again, because I'm gonna do it with you later on. So I won't go in detail. So you can actually, okay, Tava's coming in and Zoom user, which I'm assuming is still Anu, is coming in again. Ashman also came in. For those of you who just came in, please edit your own name, yeah? Okay, so how did they get red color here? What do you think they put in to get red color? Glitter, no. You cannot put glitter. So how does your candy become red in color when your mother makes candy? What does she put? Actually, I think I missed out Aaron's name. Can I have Jerry, if you don't mind getting Aaron? Thank you, Jerry. Food coloring, correct. Okay, good. You're gonna add food coloring inside. Okay, you put food coloring. So the one on my right hand side here, they didn't add anything at all. Okay, they left it pure like that. Okay, so it depends on you when we do this experiment. Not maybe 2-3 weeks from now, you can actually bring your own food coloring. Some of my students even want to make it smell nice. They brought flavoring. Sorry, they brought lavender. They brought lavender. They brought all sorts of things to make it smell nice. It's up to you. Vignesh, once your brother Lavi, he bought, I think, he brought prayer oil, or he brought one kind of oil. Okay, and then when we were doing it, it began to become so volatile that I had to stop the experiment. Okay, so please don't bring the same soap and come, same oil and come. Okay, bring proper oil. If anyone wants to bring a reused oil, you can. Okay, so this was 2021. Okay, you can see some of them, their names are here. Irina, Wenglia. A lot of them, they also made soap. Some jadi, some tak jadi. Yeah? If you don't dry it properly, you can actually see that it doesn't turn out well. Here, this one, my student put lavender. So it didn't become quite nice because the lavender went in like that. Okay, you should bring lavender oil or scent. Don't bring the lavender, the biji, okay? This is another class that did. How good is the soap at cleaning stuff compared? Oh, no, no, no. Don't use this soap to clean anything. We are just making soap. We have never tested the soap. Ashman, if you would like to try, you can be the first one to try. Okay, Ashman?
Good idea.
Sorry, Anu? Anu, you're not muted.
Oh, sorry, Joe.
Okay, thank you. Yeah, so this is interesting. Teacher will do this with y'all, okay? And then we do some observation, and then we'll do some questions as well. Okay, that is so. Now, how do we differentiate?
Teacher, Aaron said he's in another tuition.
Cannot. He didn't inform me.
He said he'll inform you now.
Tell him I'll beat him before he informs me, okay?
Okay.
It's as though y'all don't know the procedure. I mean, then we shouldn't have had the class at 4. If so many of you cannot make it, it doesn't make sense to actually discuss next time. Teja too. Teja just informed teacher he cannot make it. So the majority of the class is not here. So many not here. What's the point of having the class then? Okay. Now, detergent is any cleaning agent that is not a soap. Okay, so where does detergent come from? Detergent actually comes from petroleum. Okay, and they are sodium salts of sulfonic acid. Okay, did I ever teach you anything that sounds like sulfonic acid? Think. Anything that I've taught you about sulfonic or sulfuric acid? Do you remember sulfuric acid? Anyone can remember sulfuric acid? Correct, very good. Okay, it's H2SO4, well done. Okay, so let's have a look at how does the sulfonic acid looks like. Okay, so I've got 2 common detergents that we use. Okay, so the first one is sodium alkyl sulfate. Look again, in any soap or detergent, I must have sodium or potassium. Okay, alkyl is always the R group. See the word alkyl here? Alkyl is always R. and then sulfate. So many of you know that sulfate is SO4. So that's why here we have SO4. So that's your word sulfate. Okay, so the first one that you can know for detergent is sodium alkyl sulfate. The second one, same, very similar, sodium. And now it's alkyl benzene. Okay, this is your benzene ring. Okay, a benzene ring is always something like this. Okay, I work either way. So this is your alkyl benzene. Okay, and this is your sulfonate. Teacher, why does now got sulfate, now sulfonate? What's the difference between the first detergent and second detergent? Very good. Okay, here teacher only has 3 oxygens. So when I've got 3 oxygens, it's called a sulfonate. If it's 4 oxygens, it's called a sulfate. Now you tell teacher, what was the difference between this sulfate and the soap I taught you just now? What does sulfate has that soap don't have? Sorry, what does detergent have that sulfate don't have? Sorry, what does detergent have that soap don't have? I repeat, what does detergent have that soap don't have? Very good. Good one, Ashman. It is sulfur. So whenever you see sulfur in this topic, oh, this is a detergent. Whenever you see COO, you know that's a soap. Very easy to differentiate the both. One is detergent, one is soap. Cannot go wrong. Detergent got sulfur. Soap doesn't have sulfur. Okay, now, in your entire life, you have used a lot of soap and detergent, but you never realize that actually there's a mechanism to it. Okay, so today, teacher's going to teach you the mechanism. Okay, why do we have soap and detergent? Okay, because actually soap and detergent, they lower the surface tension of the water. What does that mean? Okay, so because water is held together by hydrogen bonds. Okay, this is oxygen. Oxygen will bond to another hydrogen. Okay, and this hydrogen has O and H. So this is a hydrogen bond, and the bond goes on and on and on and on with many water molecules because I've got this hydrogen bond. Therefore, my surface tension of water is very strong. Okay, very strong, very high surface tension. That's why what's the name of that insect that can walk on water? Daddy long legs, right? Daddy long legs can walk on water because of the high surface tension of water. Skater, yeah, could be. All right, okay. So when soap and water comes in, sorry, soap and detergent comes in, this one breaks. Okay, the hydrogen bond breaks. And when the hydrogen bond breaks, okay, my surface tension becomes lower. And then the oil and grease will emulsify and then it will come up into suspension. So I will teach you step by step how it happens. Okay, look at this. Is this a soap or is this a detergent? The one teacher put in a segi empat. Soap or detergent? Very good, soap. Okay, now, I want to tell you something. How many of you went for, what was the latest concert recently? Any latest concert? Not Coldplay. I know there was another concert recently. Always before chemistry exam, always got one concert. Yeah, is it Taylor Swift? Is it? I can't remember. I know before chemistry trials was on, it was Coldplay. Was it Taylor Swift recently? Okay, so let's say it was Taylor Swift. Okay, even if you went for Taylor Swift concert or you didn't go, it didn't matter. Okay, because it didn't matter. Okay, that's my point here. This is a soap, sodium palmitate, which is a soap. How do I know it's a soap? Because I've got COO. Now, when I ionize it in water, I ionize it in water. I taught you last year when I ionize means I break the positive and negative bond. I will get the soap anion and I'll get the sodium ion. Okay, this is you not going for Taylor Swift concert. Whether you went there or not, it doesn't matter. You're not important in this equation. The sodium ion, not you. the sodium ion. But this is Taylor Swift. The soap anion is Taylor Swift. She is super duper important. Okay. And if she is not there, there's no concert. Okay. So most important that you need to know here is when I put soap in water, I will get Taylor Swift and I'll get you. And Taylor Swift is important. At the concert, only at the concert. In my life, Taylor Swift is not important. You are more important. So the other way around. Okay, but now we're not talking about it. Now we're talking about ionization of sodium palmitate. All right, so get the point here. Do you understand what teacher is saying? Yes? All right, good. Okay. Okay. So point is, I want the soap anion. It's very, very important. Now, soap anion. This is my lovely, lovely soap anion. Okay. Now, in the soap anion, I've got two parts. The first part is hydrophilic. The second part is hydrophobic. The name already says it for himself. Hydrophobic. What does it mean? Very good. It repels water. I don't like water. Okay. Hydrophilic means I love water. Okay. So that means to say when I put this hydrophobic and hydrophilic part in water, the hydrophobic part will go and immerse itself into the grease, and the hydrophilic part will be the one that's staying in water. Teacher, I don't know what you're saying, teacher. So let's look at the diagram. And my slide won't go. Okay. So detergent also same. Huh? How do I know this is a detergent? How does teacher know that? Straight away, I give one look, I know it's a detergent. How come? What tells me it's a detergent? Sulfate or sulfur? Yeah, okay, correct. Okay, so I have a sulfur here as well. So remember, when a detergent ionizes in water, whatever sodium ion or potassium ion is not important as well. I only want the anion. Okay, remember, only the anions are important. Okay, same thing. The sodium anion, sorry, the anion, I've got the hydrophobic part and I've got the hydrophilic part. Hydrophobic don't like water and it's always the R group. Do you know what this cabang is? These mountains, climb every mountain. Do you know what this mountain is? Just say yes or no. It's okay. If no, teacher will teach you. Okay, very good. So this is a CH3 group here. CH3 group here. So when you go to upper levels from 6 or whatever, or if you do the quiz kimia kebangsaan, they will have this. This is all your CH3, 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 CH3. So this is your mountains. Okay, for each line it resembles one CH3 group. Okay, so that is what that line is all about. So in case you're wondering, okay. Now, same thing when I put it into water, I've got hydrophobic, and I've got the hydrophilic part. Okay, so you know the hydrophobic part will be soluble in oil. The hydrophilic part, hydrophobic in oil, hydrophilic in water. Okay, so point number one, there's only a few points that you need to know here. When I put soap in water, point number one, it will reduce the surface tension of the water. Okay, and then when the surface tension of the water is lowered, the molecules will spread out, the water molecules, and the water will be, and it will wet the cloth. So soap, we say here, is wetting agents. I don't even see why this is an important point, but it's okay. It was in the textbook as well. Okay, this is actually your dirt or your grease. Okay, this is your grease. This is the cloth. And this is what's happening actually. When you put soap or detergent in, remember I told you all your soap cation ion is not important. That's why it's not playing a part. But if you look at your anion, the hydrophobic part is going into the grease because it's soluble in grease. And the hydrophilic part is staying in the water. You look at every one of it. Everyone follows that format. Okay. All the anions, the hydrophobic is going into the grease and the hydrophilic is going into the water. Okay, and you see all of it, all of my anions is playing a part here. All my cations are doing nothing. Okay, so when the water is agitated slightly, now the grease is begins to be lifted up from the surface. So that's very interesting. Okay, it's because of that soap lifting and because of the agitation of water, or when you agitate the clothes, when you're using your hand to wash it, okay, and mechanical agitation. Nobody wash clothes, you just stare at the clothes. I think your mom will give you a smack if you just stand there and then look at the clothes. I'm washing my clothes, mommy, but you don't even use your hands to actually agitate it. Cannot. Okay, so you must use mechanical agitation. Okay, during scrubbing, it will help to pull the grease free, and it will also break the grease into smaller droplets. So can you imagine if you're washing a big chunk of dirt, okay, and you're scrubbing it, does it stay big, the whole chunk of dirt, or will it eventually break into smaller droplets? Go back and think back of the time that you've washed your clothes. If anyone has not washed clothes before, please let me know. I'll bring some dirty clothes, grease clothes to school, and then I'll make you do the experiment, do some washing. Okay, does it stay in, does it break into smaller droplets, or does it stay as a big dirt altogether when you do washing? Okay, it breaks into smaller droplets. Okay, it breaks, correct. Okay, so actually what happens is something like this. So I'm not going to give you an experiment where you go back home, you're already at home, and you're going to put chili sauce on your clothes, and then you take soap or detergent and clean up. Okay, your mom will probably come after me and ask me, why, Panchina, you're doing this to my children? Okay, no need, but you can get the concept. So why do you think these droplets do not coagulate? So now they are already in smaller droplets ready. Why do not they combine together and they become one whole big molecule one more time? Why? If you look at the diagram will give you an idea. Yes, okay, very good. They are all negatively charged. Because they are all negatively charged, I taught you in polymer already. Okay, because they are all negatively charged, okay, when they are negatively charged, then they will repel each another, so they will never coagulate again. Coagulate, I taught you in chapter 4, they won't combine together and become one more time. Okay, after this happens, the droplet will be suspended in water. It will rise up and it will cause an emulsion. So whenever you're washing clothes or dirty things or dirt or whatever, you can see always the dirt comes up and forms an emulsion. Okay, so we say that soap and detergent are actually emulsifying agents. Okay, and then when you rinse away all this, you will get a clean surface. Now, I'm sure none of you ever thought Panchina will ever teach you about the mechanism of washing clothes. Okay, all right. But here we are, okay, learning about the mechanism of washing clothes. All right. So this is something, has it come out in exam? Yes, it has come out in exam before. But what is more important in exam for this chapter was the first part teacher taught you, and the next part that I'm going to teach you. Okay, all these are additives. What do I add into a detergent? That is important. This one usually come out for objective only. Okay, so teacher adds a builder. Okay, I enhance the cleansing efficiency by softening the water. Came out in objective before, so at least you need to take note as well. I add a suspension agent. I prevent the dirt particles from going back into the clean fabric. So I must have suspension agent. If not, whatever dirt will go back into the clothes. And what for you wash the clothes? No point, right? Okay, you have drying agent. This is important. You've got biological enzymes. Sometimes you've got oil, you've got blood. Okay, you want to remove them. So teacher has blood biological enzymes in it. All these are in your detergent, yeah? So I'll teach you shortly after this, Ashman, because I'm going to teach you hard water just after this. Okay? Builder, I want to soften hard water. So I'll teach you a bit now. Hard water has calcium and magnesium ion, and it's not good. Not good. Because soap cannot work with calcium and magnesium. Okay, so I put builder, then I try to make it softer. Okay, whitening agent, sodium perborate. Okay, I want to decolorize it. Okay, you want to put brightener. No one wants to wear a dark clothes. Tanisa, you're not muted, darling. Okay, add brightness. Okay, all this you can actually read. Okay, perfume, you want to make your clothes smell fresh and clean. Okay, so all of these are additives, not important for structure, but very important for objective. Now, what I'm going to teach you here is very important for structure and essay. Okay, after doing this, I've done the chapter on oil and fat and soap together. Teacher did it. Okay, and then teacher will go to medicine and food additives. Okay, now when I have hard water, soap function is not good. Why? Very important class, because hard water has calcium and magnesium ion. Teacher, where can I find calcium and magnesium ion? Where? Okay, so two places. Okay, sea water. Okay, and well water. Okay, two places that we know so far, sea water and well water. Okay, what will happen? Teacher, why it's not good? Okay, I want to remind you. So I told you just now that soap is RCOO minus Na. Na, I don't care. So it's RCOO minus. When I have calcium ion or magnesium ion coming in, they will go and react with the this anion here, and it will they will form an insoluble precipitate. Another name for this insoluble precipitate is called scum. Now, if what happens is you become something like this, okay, don't look at the balancing or whatever. Okay, if it becomes something like this, then teacher got no more soap, and my soap will not function as soap anymore, and then soap is wasted. So point number one, if the question asks you, why is soap not effective in hard water? All of you must say, point number one, all of you writing with teacher, yeah? Why is soap not effective in hard water? Okay, point number one. Okay, hard water contains calcium ion and magnesium ion. That's your point number one. Okay, hard water contains calcium ion and magnesium ion. Okay, then you must say calcium ion and magnesium ion, okay, will react. If you don't write down the word react here, you don't get the answer. Will react with soap. Some students put add, will add with soap. Cannot, no marks. Okay, with soap and ion, this is your second mark. Okay, and then the third mark will be to form. Now you can make it easy by putting the word scum. Or you want, let's say you're not confident of the word scum, you can put insoluble precipitate. Okay, to form insoluble precipitate, and you would get full 3 marks here in your answer. So you can answer the question that they will ask for this is, why is soap ineffective in hard water? Okay, that is point number one. Okay, point number two, do you know that soap also cannot react with acid water? Why? Same thing, I told you soap is RCOO minus. If teacher put a hydrogen, because acidic water got hydrogen, hydrogen will come here. Is there any more soap anymore? Any more soap and ion? Can you tell teacher? Is there any more soap and ion here? If the hydrogen come in, do I have any more soap? Or has it become a carboxylic acid already? Teacher wants RCOO minus. But when teacher add in hydrogen, it becomes RCOOH. That means it is no more a soap. Is that helpful? Is this a soap? RCOOH, is it a soap? No. Okay, if it's not a soap, is it going to be effective in acidic water? Okay, no, it will not be effective in acidic water. Same concept. Okay, you can say the hydrogen ions will react in the acidic water with soap, to form a long chain fatty acid. See, teacher told you, I'll get a long chain fatty acid. Okay, so it will be insoluble and it will not function very well. Now, let's look at detergent. Detergent, okay, it is such a good person and such a good boy. Detergent, it does not form scum. Okay, it forms soluble substance with calcium and magnesium ion. That means when the detergent reacts with the calcium and magnesium, no precipitate is formed. Same thing with the acidic water. So it is very good in hard water. So teacher want to ask you all answer my question. Class, is detergent effective in hard water? What's my answer? Yes, it is effective in hard water. Why? Why is it effective in hard water? Why? So very good. All of you very clever. Yes. Okay, yes. Why is it effective in hard water? Just like how I taught you just now. What's the step? The first one we know is not effective in hard water for soap. Because hard water got calcium and magnesium. Very good. It contains calcium and magnesium ion. Okay, what does the calcium and magnesium ion do? Will react with detergent and ion. Okay, it will react with the detergent and ion. Yes, very good. Very good. To form soluble substance. Very good. Okay. Perfect. You get 1 mark here, 1 mark here, 1 mark here. Perfect marks. And this is and you can say it will not form scum. Okay, it does not form scum. Okay. Jerry, not to form scum, it will not form scum. Okay, now let's see, we always say soap not so good, detergent better, but let's see, compare now. Okay, soap comes from animal fat or vegetable oil, detergent come from petroleum. Must know the difference, huh? Soap only in soft water. That means any other water besides seawater and well water. Okay, but detergent, both also jadi, both also very good. Okay, soap it will form scum and precipitate in hard and acidic water. Detergent, good boy, all can. But the sad part about detergent is they are non-biodegradable. So that's the only bad part about it. But soap, they are biodegradable. So there's no problem. Soap is very, very good. Okay, after this, I have all questions already. So teacher won't go to the questions now because I will prepare some other questions for you all. Okay, so so far, do you all understand what teacher is saying? Do you get what teacher is saying here? Do you all get it? Do you understand so far? Because teacher has done so. Yeah? So far. Okay. Now, teacher give you 1 minute. I am now going to go. My battery is running low. So I'm going to give you 1 minute. Go drink water. I'll probably take another half an hour. I think I don't want to go so long. I want to finish medicine. And I want to finish food additives. Okay. And then teacher got 2 more very small parts. Okay. That teacher will do much later when I can. So go drink some water while I go charge my laptop as well. Teacher want to remind your class, if you know that you are not able to come for class, I already told you already. Okay? That you need to always inform teacher. Okay, so you cannot say, teacher, I don't know, teacher, I forgot, teacher, or whatever. And always discuss with the class. What is the good time for everybody? Cannot just only one set of group of students can make it and then the rest cannot make it. You can always find the best timing.